Hi, I am Yannick Moy from 8d.mp4. This is the 8th challenge in the Find a Bug series. This time, we're interested in the behavior of voting machines. Vendors say that they don't have bugs, right? Well, here we have the source code, so let's check it with CodePeer. First, let me show you around the code quickly. So you have IDs and positions to identify voters and their menu, two kinds of votes, referendum and election, ballots, and machines. Notice that machine is a tag type which is derived in two different machines for the two types of votes. There are procedures to get the vote, to count them, and to analyze them. Here are the definitions. And finally, the polls function creates a suitable machine for the election and goes through all the steps. Let's run CodePeer now. As you might expect if you have followed previous challenges, CodePeer issues warnings for potential errors. Here it issues 4 warnings. The first one claims that function analyze requires that m.score is initialized. If we look at the precondition generated by CodePeer for function analyze, here, we see indeed that the pseudo ADA attribute m.score tick initialized is here, which says so. It is correct because the body of analyze reads the value of m.score. Looking now at the body of polls, we see that the procedure count is called just before the call to analyze. So we could expect that this call sets m.score. GPS automatically highlights dispatching calls in different color. Here display yellow. So here the call to count is dispatching, and we should check the overriding procedures possibly called. Here, this is the count procedure on the referendum machine over there. It does set the winner component here, but never the score component. So let's fix that. Now we're going to look at the other count procedure for the election machine, which has the same problem, so it's the same solution. Let's now rerun CodePeer. That's okay now. So the second warning now complains about a useless assignment to local variable win. CodePeer says it is a self-assignment, meaning that the value assigned to win, true here, is already the value of win at this point. Indeed, looking at the occurrences of win in this function, we see that it is initialized to true. The problem is that when the score of the false ballot is greater than the score of the true ballot, the false ballot should win. So we should really assign false here. So let's correct that. It's very typical for the user to pick the wrong value when there is a Boolean assignment, and here CodePeer can help. The third assignment is similar, even more self-explanatory. Scores of votes is assigned to itself. As we're counting votes here, scores of votes should really be incremented so that a +1 was meant. Like that. The last warning is about some dead code in a branch, meaning that the test for this branch is always false. Indeed, execution reaches this point only when the first test is false, here. So that fraction cannot be greater than 0.65 on this line. The order of tests should really be changed, so let's do it. And now let's rerun CodePeer. As an aside, the strange fractions mentioned in the previous warning come from the machine representation of .5 and .65, which are close to the real numbers but not exactly equal. And you see we're done. No more high and medium warnings. And thanks for watching this demo. If you're interested, there's more on our website www.8record.com. Ciao.